Alright guys, today I'm going to go ahead and show you how to draw a Bohr model for sulfur, and that's going to be your example on how to draw Bohr models in general. So the first thing we're going to look at is determining the subatomic particles. In this case, sulfur, we're going to look at the atomic number, which is right there, and that will tell us that it has 16 protons, and then protons and electrons are always going to be the same, because the positive and the negative charges will cancel each other out, making the atom electrically neutral. And then for our neutrons, it's going to be our atomic mass minus our atomic number. Okay, so in this case, we're going to round that mass to 32. So it's going to be 32 minus 16, which is our atomic number, giving us a grand total of 16. Now that we know that information, we can go ahead and draw its nucleus. We're going to make the nucleus yellow. Okay, so here's a nucleus. And inside the nucleus, you're going to have the protons and you're going to have the neutrons. Okay, so we know that we have 16 protons and we have 16 neutrons. Okay, now we're going to go ahead and draw the rings. Now, if you look on the periodic table, you're going to see that sulfur is on the third row. Because it's on the third row or third period, it's going to have 3 rings. Okay, so we're going to draw 3 rings around it. So here's the first, the second, and the third ring. Okay, from your notes, if you recall, it tells you that on the first ring you can fit up to 2 electrons. Remember that we need a total of 16. So we're going to go ahead and put them in pairs. So here's my first 2. Okay, on the second ring we can fit up to 8. So putting them in pairs, and I'm going to go ahead and follow along with the clock model of putting the electrons, and so we can keep it consistent. It's going to be one at 12 o'clock, the other one at 3 o'clock, the other one at 6, the other one at 9. Okay, remember we're going to fit up to 8. So therefore, we're going to go around it again in a clockwise fashion and double them up. So that's 1, 2, remember from the first ring, and then 4 on the second ring so far. So we're going to put the other 4. So that's 7, 8, 9, 10. Okay, so we have 10 electrons so far. Now all we need is 6. Now, granted that on the last ring, which is the third ring, we can fit up to 8, but we only need 6. So we're going to go ahead and do the same method. Start up top. That's 1, 2, 3, 4, 5, then 6. Okay, and these are the valence electrons. The valence electrons are always the ones on the last ring, the outermost ring. And the reason these are important is because those are the electrons that are responsible for bonding with other elements or other atoms, and so they make compounds. So they're the socializing electrons. And you can never ever have more than 8 valence electrons on any atom on the periodic table. And also, when you're drawing your electron dot structure, which shows the number of valence electrons, this is what you do. You draw the symbol of your element, just like that, and you're pretty much going to copy the valence electrons that you see on the Bohr model. You can also look on the periodic table, and it would be on the 6th group, so you can go ahead and say that it would have 6 valence electrons. So counting from here, or we can simply just copy down the valence electrons that we see. Let me just show you. Let's do green, You can pretty much just copy these right here. Okay? And so you've got 2 on the top, 2 on the side, 1 on the bottom, and then 1 on that side. Okay, and once again, that's its Lewis electron dot structure, and this is a Bohr model for sulfur.